In this episode, we're going to make the shared responsibility model feel concrete and usable, because most cloud security failures are not caused by a missing feature, but by a misunderstanding of who was supposed to do what. Beginners often hear the phrase shared responsibility and assume it is a simple split, like the provider handles security and the customer handles everything else. In practice, it is more like a set of overlapping handoffs, where responsibilities change depending on the service, the configuration, and how you use it. The danger is that gaps form in those handoffs, and those gaps can sit quietly for months until someone exploits them or a mistake exposes them. Our goal is to help you recognize the common gap patterns so you can spot them quickly on the exam and in real environments, even when the scenario uses different terminology. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good way to begin is to define what shared responsibility actually means at a high level without turning it into a slogan. The cloud provider is responsible for securing the underlying infrastructure that delivers cloud services, such as the physical facilities, the core networking, and the platform components that customers cannot directly control. The customer is responsible for securing what they build and configure on top of those services, including identities, access policies, data handling, and many service-level settings. The key detail is that the boundary is not always at the same layer for every service. If you run a virtual machine, you own more of the stack than if you use a managed database, because the provider takes over more operational responsibility in managed services. Shared responsibility is not a static line. It is a shifting boundary that depends on what you consume. A shared responsibility gap is created when you assume the other party is covering something that is actually your job. These gaps often appear because cloud services are easy to adopt quickly, and the easiest path is not always the safest path. A team might think the provider automatically restricts access to data, when in reality access is controlled by customer-managed policies. A team might think the provider monitors for all suspicious activity, when in reality the customer must enable logs, route them, and respond to alerts. A team might think a managed service implies full security management, when it may only imply infrastructure maintenance and availability. The gap is not always a mistake in configuration. Sometimes it is a missing decision that nobody realized they had to make. Identity is one of the most common gap areas because people intuitively expect identity to be a platform feature that is safe by default. Providers do offer strong identity capabilities, but customers still decide who gets which permissions and under what conditions. If you grant broad administrative roles for convenience, the provider does not know your intent and will not automatically reduce those permissions for you. If you fail to separate human administrative access from service access, the provider will not automatically design that separation on your behalf. If you allow long-lived credentials to exist without rotation or oversight, the provider will not magically correct your operational hygiene. Identity gaps often stay hidden because everything appears to work, and working systems can be dangerously misleading when the permissions model is the real vulnerability. Access exposure is another shared responsibility gap that shows up constantly, especially with storage and network-reachable services. Providers give you the ability to make resources public, private, or shared, but the provider cannot decide what you intended. A storage bucket can be secured tightly, but it can also be open to the world with a small misstep, and the platform may still behave exactly as configured. The same is true for databases, message services, and application endpoints. Reachability is a customer decision in most cases. Beginners sometimes assume the provider would block obviously unsafe exposure by default, but the provider often prioritizes flexibility and allows you to create public services because many legitimate architectures require public access. The gap happens when a team creates public access unintentionally or without the necessary compensating controls. Patching and vulnerability management is another area where cloud can confuse beginners because responsibility varies by service type. If you are running virtual machines, you are typically responsible for patching the operating system and the software you install, even though the provider runs the physical hosts and core virtualization. If you are using a managed database, the provider may handle patching of the database engine, but you still manage account permissions, network exposure, and how data is accessed. The gap forms when teams move to cloud and assume patching becomes a provider problem across the board. That assumption can leave workloads running outdated components for long periods, especially when teams also lose their old patching routines during migration. The exam tends to reward your ability to notice these boundaries and identify who must act when a weakness is discovered. Logging and monitoring is a shared responsibility gap that is especially quiet because the absence of evidence can feel like evidence of absence. Cloud platforms can generate detailed logs for management actions and service access, but customers often must enable them, choose retention, and route them to a protected location. If you do not do that, nothing may look broken, but your environment becomes a place where an attacker can operate without a strong audit trail. Another gap is assuming that the provider will notice suspicious behavior and alert you, when in reality detection often depends on customer-defined rules and review routines. Even when default logging exists, it might not cover the specific events you need for investigations, or it might not be retained long enough to reconstruct a timeline. A monitoring gap becomes real exposure because it shortens your time to detect and increases the time an attacker can remain active. Configuration management and drift are also shared responsibility challenges because the cloud is configuration-driven. The provider supplies the service, but the customer defines how that service is configured, and configuration is not a one-time event. Teams change policies, open firewall rules temporarily, add new roles for a project, and create new resources quickly, and those changes accumulate. If there is no strong review process or automated guardrails, the environment drifts from the intended posture. The shared responsibility gap is assuming the provider will enforce your internal standards or keep your configuration consistent over time. Providers offer tools that can help you enforce policies, but choosing, configuring, and maintaining those guardrails is a customer responsibility. Drift is quiet exposure because it happens in small steps that each seem reasonable in isolation. Data protection is another gap area because people equate data protection with encryption and stop thinking. Providers can encrypt data at rest and in transit, and that is valuable, but customers still decide who can access the data, how long it is retained, and how it is used. If sensitive data is stored in a location with broad read permissions, encryption does not stop an authorized identity from retrieving it through normal service interfaces. If backups and snapshots are retained indefinitely without access restrictions, the environment accumulates high-value targets that an attacker can exploit later. If data is copied between environments without clear classification rules, it can end up in places with weaker controls. The shared responsibility gap is assuming the provider's default protections automatically match your data sensitivity and regulatory needs. Another gap pattern appears in network design, where customers assume segmentation exists because the platform supports it. In reality, you must design segmentation and enforce it through routing, firewall rules, and service-to-service trust decisions. Providers give you primitives to create private networks, separate subnets, and control traffic flows, but they do not decide which workloads should be isolated. A common gap is leaving broad internal connectivity because it makes troubleshooting easier and then never tightening it. Another gap is leaving outbound traffic unrestricted, which gives attackers easy paths for command traffic and data exfiltration if they get a foothold. Network gaps can be quiet because applications still work, and success can hide the fact that trust boundaries are missing. Shared responsibility gaps also show up in incident response expectations, which beginners often overlook because they imagine incident response as something you do only after something goes wrong. Providers may handle certain infrastructure failures and may offer security support services, but customers still have to build their own detection, triage, containment, and recovery processes for their workloads and data. If you do not know how to revoke compromised credentials, isolate affected resources, and preserve evidence, then you are exposed even if the provider is doing their part. Another gap is failing to test recovery assumptions, such as whether you can restore data, rebuild systems, or re-establish access safely after an incident. The provider can provide resilient infrastructure, but your organization must practice how to use it under stress. The quiet exposure is not a missing tool, it is a missing plan. A powerful way to spot gaps is to listen for assumptions in how a scenario is described. When you see language like the provider will handle security, the cloud is secure by default, or the service is managed so we do not need to worry, treat those as red flags that a gap might exist. Then ask yourself what the customer still controls: identities, access policies, network exposure, data classification, logging, and operational routines. If the scenario shows rapid growth, multiple teams, or frequent changes, expect gaps around governance and drift. If it involves sensitive data, expect gaps around access control and retention. If it involves production systems, expect gaps around monitoring and incident response. This method is calm because it is systematic, and it turns vague claims into specific questions you can answer. As we close, the shared responsibility model becomes practical when you stop treating it like a diagram and start treating it like a checklist of handoffs that must be owned deliberately. The provider secures what you cannot control, but you must secure what you build, especially identity, access, data handling, configuration, and monitoring. Gaps form when someone assumes the other party is covering a responsibility that is actually theirs, and those gaps often stay invisible because nothing breaks immediately. The best exam-ready mindset is to look for boundaries that shift by service type and to identify the customer actions required to turn strong cloud capabilities into actual security outcomes. When you can spot shared responsibility gaps quickly and explain why they matter, you are much less likely to accept quiet exposure as normal, and you will be ready to choose the safest answer when the exam presents a scenario that tries to hide the gap in plain sight.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.